For most of human history, the universe was something we looked up at but never truly saw. The stars shimmered above us, blurred by atmosphere, distorted by the thin veil of air that protects our planet. We could measure their positions, we could map their movements, but the deeper universe remained hidden, just beyond our reach. In the 1960s, that began to change. Small scientific instruments were carried briefly above Earth's atmosphere aboard sounding rockets. They were crude by today's standards, fragile, experimental, often uncertain. Yet, in those few silent minutes above the sky, they detected something remarkable. Invisible X-rays, ultraviolet light, radiation from violent cosmic events no human eye had ever perceived. For the first time, we were not simply observing the universe, we were discovering that it was far more energetic and far more complex than we had imagined. By the 1970s, a bold ambition emerged to place a permanent observatory in space, a telescope free from atmospheric distortion, a mirror polished with almost unimaginable precision. It would orbit above Earth and stare into the depths continuously. The result was Hubble. When it launched in 1990, expectations were immense, and yet the first images returned were blurred. A flaw in the mirror, no wider than a fraction of a human hair, had compromised its vision. It was a humbling reminder of how unforgiving precision can be at cosmic scales. But the story did not end there. In a feat of engineering and human resolve, astronauts traveled back into orbit. They repaired the telescope by hand, installing corrective optics in the vacuum of space. When Hubble opened its eye again, the transformation was extraordinary. The universe came into focus. Galaxies appeared where darkness had once seemed empty. A small patch of sky, no larger than a grain of sand held at arm's length, revealed thousands of galaxies, each containing billions of stars. It became clear that the cosmos was not sparsely scattered with islands of light. It was overflowing with them. As the years passed, our vision expanded beyond visible light. Infrared telescopes allowed us to see through cosmic dust clouds where stars were being born. Regions once thought opaque became luminous with hidden structure. The universe revealed layers, each wavelength exposing a different story. And then, in the early 21st century, a new observatory prepared to take its place in history. The James Webb Space Telescope unfolded in space more than 1 million kilometers from Earth. Its golden mirror segments aligned with exquisite precision. Its vast sun shield protected it from the warmth of our star, allowing it to detect the faintest heat signatures from the distant past. When Webb's first images were released, they showed galaxies so ancient that their light had traveled for more than 13 billion years to reach us. We were no longer just observing distant objects, we were witnessing the early universe. Webb's instruments began analyzing the atmospheres of planets orbiting other stars, traces of water vapor, carbon-based molecules, chemical fingerprints that on Earth are associated with life. For the first time, humanity could examine the air of worlds beyond our solar system. By the 2030s, space telescopes no longer operated in isolation. Arrays of spacecraft flew in coordinated formations, combining their light to simulate mirrors far larger than any single structure could achieve. Observatories were placed in deep space at gravitational balance points, even across the far side of the Moon. Together, they began to image planets resembling our own, distant spheres with clouds, oceans, and weather systems orbiting foreign suns. Each discovery brought clarity, and each clarity revealed deeper questions. As our instruments improved, we turned them toward the faint glow of the earliest stars, the first points of light to pierce the primordial darkness. We mapped the distribution of hydrogen from the cosmic dawn. We observed black holes shaping entire galaxies. And eventually, we reached the boundary imposed not by distance, but by time. There exists a limit to what we can observe, a horizon defined by the age of the universe itself. Beyond it, light simply has not had enough time to arrive. Our telescopes peer into that deep field where light thins and radiation fades into near silence. It is not the edge of space, it is the edge of the observable. From fragile rockets in the 1960s to vast coordinated observatories spanning thousands of kilometers, the evolution of space telescopes reflects something fundamental about our species. We are driven to see, to understand, to locate ourselves in the immensity that surrounds us. And after decades of refinement, risk, failure, and discovery, the most powerful image may still be the simplest: a small blue world suspended in darkness. Every mirror polished, every launch undertaken, every instrument aligned with microscopic precision, all of it to better understand that single, fragile point of light and our place within the cosmos.
Please like and comment the video. Subscribe for more updates. Thank you.